We need to obtain derivative of y with respect to x whenever we have y given in this implicit form. So let's begin. So here we are given y equals to b times inverse tangent of x over a plus tangent inverse of y over x. Right. Well, we will divide both sides of equation number 1 with b. So this gives us y over b equals to tangent inverse of x over a plus tangent inverse of y over x. Now we're going to take the tangent on both sides. So we have tangent of y over b equals to x over a plus tangent inverse of y over x. Right. Now we'll multiply throughout with a. This gives us a times tangent of y over b equals to x plus a times tangent inverse of y over x. So we have simplified equation number 1. Now what we'll do, we'll take the derivative on both sides of equation number 1 with respect to x. So let's do that. So here we have a is a constant, so a will be multiplied to derivative with respect to x of the tangent function. We have tangent of y over b, which will be equals to derivative with respect to x of x plus a times derivative with respect to x of the inverse tangent of y over x. Right. Now we know that the derivative of the tangent function is given derivative with respect to u of tangent of u. So that simply equals to secant squared u. And here we also have to take the derivative of the inverse tangent function. So derivative with respect to u of inverse tangent of u. So that's equals to 1 over 1 plus u squared. Right. Now let's obtain the derivative. So we have a multiplied to secant squared y over b. So here u is y over b, but we'll have to take its derivative. We'll have to multiply it to the derivative of y over b by using the chain rule. So this will be equals to derivative of x with respect to x is 1 plus a times the derivative of the inverse tangent function will be 1 divided by 1 plus y over x whole square. So this will get multiplied to derivative with respect to x of y over x, obtained as a consequence of the chain rule. So we'll now have a multiplied to secant squared y over b times, so here b is a constant, so we can pull it out of the derivative. So we'll have a over b. This will be multiplied to derivative of y with respect to x, which is equals to 1 plus. So we have a. So here we're going to multiply both numerator and denominator with x squared. So we have x squared divided by x squared plus y squared. Now we'll have to take the derivative of y over x. For this we're going to use the quotient rule. In the denominator we have x squared, and in the numerator we have x multiplied to derivative of y with respect to x minus y times derivative of x with respect to x. Right. So this x squared and x squared goes away, and now we are left with a over b times secant squared y over b times derivative of y with respect to x equals to 1 plus a divided by x squared plus y squared whole multiplied to x times derivative of y with respect to x minus y times derivative of x with respect to x. So that's simply 1. Right. So let's further simplify it. So we have a over b times secant squared y over b times derivative of y with respect to x, which will be equals to 1 plus. So we're going to multiply a over x squared plus y squared with each of the terms within the parentheses. So we have a times x divided by x squared plus y squared. This will be multiplied to derivative of y with respect to x minus a times y divided by x squared plus y squared. Now we'll combine this term and we will transpose the second term from the right hand side to the left hand side and combine it with the term on the left hand side. So we have a over b multiplied to secant squared y over b minus ax divided by x squared plus y squared whole multiplied to derivative of y with respect to x. So this will be equals to, so we have 1 minus ay divided by x squared plus y squared. Now what we're going to do, we're going to multiply throughout with x squared plus y squared. So we have a over b times x squared plus y squared multiplied to secant squared of y over b minus ax whole multiplied to derivative of y with respect to x equals to x squared plus y squared minus ay. Now we will finally find isolate dy over dx. So derivative of y with respect to x will be equals to x squared plus y squared minus ay. Whole thing divided by, we have a over b multiplied to x squared plus y squared multiplied to secant squared y over b minus ax. So this is the final value of derivative of y with respect to x.